This video is an understanding of how the bitwise operation on vector works. And specifically, we're looking at the not bitwise operation. So we've got a vector of numbers. We've got 8 integer numbers. And let's have a look at how this works. So how is this represented on the in C# using the tilde symbol? So the result of this bitwise operation is a new binary number where each bit is inverted from the original number. All 1 bits become 0 and all 0 bits become 1. And then each result is stored in a new vector. So let's have a look at how this is going to work. I'm going to scroll all the way down to show you the method that we're going to be calling for printing out our vector. We need to provide an operation name and also the vector itself. So that's going to print out the details of the vector. Sorry, the elements in the vector. So it's expecting 2 arguments. The first one, as we saw, was a string. So I'm going to call this bitwise not on vector 1. That's the one we got. And we're going to be passing in the vector, and it's going to be the inverse of that vector, the name of the vector, and then I'm going to, on my keyboard, shift tilde sign that's on top of the tab key on my keyboard. Could be different depending on what keyboard you've got, but that's what I've got. So let's run and see how this works and see what results we would be getting. So I'm getting this result. Let's have a look at why and how we got this. So these are my original values for the vector, positive 1 all the way to 8. So let's have a look at what is happening here. So here's our vector. I'll put it in as a comment. So the positions is per normal, but because we're working with the not, we're going to go into the negative. That's because in an 8-bit signed integer, the range is from, so the maximum is 128, sorry, 127 is the max positive, and the minimum would be minus 128 in the negative. And the leftmost bit is the sign bit. It represents negative 2 to the power of 7. That's its position. So from 0 all the way to, sorry, if that's the bit, the 8-bit number. So it starts from here, position 0 all the way to 7. So that's equal to minus 128. So this is why I've got in here. In the previous video, we didn't work with large numbers, not large numbers. We didn't work with negative numbers. So in this video, I've turned this into a negative to show that we're going to actually go into the negative and how we can calculate the decimal value. If the leftmost bit is 1, then the number is negative. So that's an inverse of, sorry, not 1. So the decimal value of 1 is pretty much only this value. So everything else is 0. Now, if we inverse the 1 into 0 and or turn zeros into 1s, that's what we get. How do we get the decimal value? In this case, we add up all of these. Now, when we add them up, these values, so these are actually 126. And then what we do in the end is we plus minus 128. So let's be lazy and I'll show you on the calculator. So let's start with the positive numbers. So 64 plus 32. So basically all of these bits are turned on, and plus 16 plus 8 plus 6. So that's 4 plus 2. And that's a total of 126 in positive. Now, because the last bit is 1, that's a negative. So we're going to add 128 and put it into the negative sign. So that gives us a minus 2. And that's why we got this output here. Now, let's do the same for the not 2. And that's the second value in our vector, not 2. So initially in the decimal point, in the binary, that's going to give us this number only. Everything else is actually 0. And every 0 is turned into the opposite, which is 1, and 1 turns into 0. So this gives us these values. So what we're going to do is we're going to add up anything that comes as the value of 1. So in this case, all of the numbers except for 2. the number 2. So we're basically adding up all of these and 1. Skipping 2 because 2 is actually 0. So the same thing, if you do the math, it actually gives you, if you add up all these values, it gives you a -3. The not 3, that's what it looks like in the binary number. And then when we invert the numbers, the opposite of 1 becomes 0 and the opposite of 0 becomes 1. Then we get a -4. And that's because we've added up these numbers. So we've skipped these first 2. Skip these first 2, yep, which gave us a -4. And the same thing, so I've got it all here. We're only, every time we do the math, we're only skipping any value that's got holding the value 0. In this case, it skipped 4. In this case, it skipped 1 and 4. 1 and 4. But you add everything else. And when you're adding that positive value to the negative value, you go into the minus. And that's, in my understanding, I feel like this is there are other ways, but in my thinking, I feel like this is the easiest way and it always works. This part here, these 2 are skipped, so we're skipping 2 and 4, but adding everything else, giving us a -7, which were here, and not 7. Again, we're not adding up the first values, which were 1, 2, and 4, giving us a -8. And for the last one, we've taken out 8 and adding everything else up, giving us a -9. So this is the result. So when we go up slightly, each result is stored in a new vector. So this is actually why we were able to pass in the vector, because the result of this operation gives us the following vector, which we can pass in as an argument and get each value of it printed in our display vector method. So I hope this video was helpful to you, and I'll see you in the next one.